Hello everyone. So today I'll be teaching you guys how to do the staircase loading in STAAD Pro. So before that, we should understand few things like how do we calculate like the base slab load, what is rise, thread, and what about the slope, all those things. So normally what happens is here you can see a step, right? So yeah, here you can see a step where this is going up like this. So whatever whatever this you guys see, the vertical length that you guys see, that is called as rise. Okay. And whatever this horizontal member that you can see, here you can see, right? Whatever this one you can see, that is called as thread. It should be placed such a way that the your foot, like whatever you keep, it should be placed there without any like disturbance. It should be placed easily. So usually what happens is we keep it around 300 or something like that. That is how it works. So normally we keep it for 300, and the rice whatever you see, no. See what happens is when someone walks, okay, is when someone walks he shouldn't have any pain when he walks, correct? When some old person or anyone of young age or something who walks, it shouldn't disturb him in any way. So that is the reason we keep this height to be 150 without any problem, without any irritation, like anything. He can walk through this step if it is 150 mm, and the foot size whatever he keeps on thread size, that is 300. So that is how it works. Now here you see a sloped area, yeah, and this is connected to a beam. So here there will be a column and it will be connected to a beam. Okay, and same is just like that, even in this case also it is the same thing. Here sometimes there will be a beam placed here. Mostly what happens is people place bricks below this, and above that they'll place this landing. So how it works is this is called as waste. Okay, waste, and there is a slope given in here, and you should make sure that the slope is properly given. So normally what happens is we give it around 40, yeah, 30 to 40 degree. So this slope whatever is there, no, we maintain it to around 30 to 40 degree, something like that. Yeah. So now once this is done, the waste is there, the rise is understood, thread is understood. There's something called as landing here. So what happens is when someone walks like this, it should be like continuous or something like that. It will be a problem to someone who's walking. So what happens? We give one place like this, then we come like this, then we go up. So we give a break here. So here, whatever the area you guys can see, no, we normally go with 1 meter, something like that. So here also it is the same. So this is how it works. And again, the same way, it goes up like this. So this is how it works, and it's going to get connected. Now, if you know this length, or the length from here to here, and if you know the height, we can calculate the slope. Correct. I mean the length by using the slope, you can calculate the length from here to here. So how do we do it? So that is the reason right now I have explained you guys so much so that you guys can understand what is this, what is waste, or what is waste lab, what is the angle between them, what is landing, what is rise, thread, all those things. So right now I can make sure that you guys have understood the basics. So let's dive into the technical thing right now. So as I've explained you guys, so what happens? This is the beam area. So what happens? Some people what they do is here there'll be a plain beam and directly they'll give this uh, staircase. Then they give landing where they'll connect the plain beam here, sometimes here. It depends on the person. It depends upon the load It depends upon the engineers, it depends on the architects how they give. So normally what happens is here there is a column, right? There are four columns, and from here there is a uh, yeah, this is a roof beam. So what happens? Let's imagine this to be a plinth beam. Okay, this to be a plinth beam. From here, I'm giving a beam and connecting the step like this, and from here there is a landing. You guys can see this landing, right? This is landing. So from here, people go like this, then they'll come like this, they'll go like this. Okay. And whatever the distance you guys can see from here to here, no, this should be around 1.2 to 1.5 because it'll be easily accessible. See, when it comes to a larger building, it changes. I can see that because it is kind of different when it comes to that. So as normal calculation, we take it like this. Okay, 1.2 to 1.5. So then the landing normally we take it around sometimes 1.5 to 2 meters, something like that. So this is how it works. Even this width also we take it at 1 meter, something like that. Okay. So this is a width to be 1 meter something, and the length depends on this one. So 1.5, 1.2 plus 1.2, something like this. So 2 to 4, 2.4. And here there will be small spacing. Sometimes they'll give so 0.5 or something like that. So it depends on the person to person how they design it. So this is the ideology. So this is how it works. Now the very important thing is you need to calculate this waste slab load. So for that you need to use this something called as Pythagoras theorem. As you guys know that we all usually calculate this. So how it works, 3, 4, 5 method, that is how the same way. So Pythagoras theorem, opposite by adjacent, that is adjacent is this one, 3 meter, and opposite. So using that we can calculate the waste slab length from here to here, whatever is there. Okay, so this is the length of the staircase. So from here to here, whatever the length is there, accordingly, using the height, we can calculate that. Okay, so from here to here, if it is 3 meters, then slab height of the slab, that is from it is like this, somewhere like this. So this will be 1.5, and the length from here to here is 3 meter. By using that, you can calculate this. So once you calculate that, using that in the coming yeah slide, I can you guys can see this one. So thread plus rise, that is Pythagoras theorem. Thread plus rise. Thread plus rise is this one. Thread and rise. Okay. The root of that divided by rise. So rise is the same thing once again. This rise into thickness of in mm. What is thickness? Whatever the waste thickness is, waste thickness divided by 1000. We convert it into meter. So that is how it works. Into 25. 25 is the density. What is this used for? This is used to calculate the volume. So I'll be showing you one of the Excel where I've done this. So you guys can have an idea. So why we have to divide this rise? The point is that is called a scaling factor. So scaling factor is used to calculate the slope length corresponding to 1 meter vertical rise. Because when calculating a load per horizontal meter, we must account for how much inclined slab length exists for the unit rise. That means how much this inclination is there. For that, accordingly, we need to calculate. That is how it works. Now, as you guys have understood the theory of this, let me go with an Excel sheet right now. So I'll be showing you guys how it works. So here this is the Excel right now. So rise is 150, thread is 300, waist slab thickness is around 150. Whatever the slope section you guys can see, there is a thickness there, so it turns to be 150. Landing thickness, the landing whatever you guys are placing, for that there is a thickness of 150. Landing slab length. So whatever slab is there, the one I showed you guys at the top, that is 1 meter. Waist slab length, waist slab is the one that we have calculated, like from the area of starting to the end, the length is there, no? Waist slab length, that is 2.48 meter. Next comes self weight of the step. So as I've told you guys, 0.5, that means half of 150. See, 150 is the rise divided by 2, that is 0.5. So divided by 1000 into 25. That is in kilometer per meter square. The same way when it comes to square root of these, this is the formula that I've showed you last time. I mean, last week, this thing, session. So this is the one. Then comes flow finish. So what happens is flow finish is like whatever the finishing that you give, whatever the concrete you're pouring. After that, you add a tile or granite or something like that. So you need to take it around 1.5 or something like that. Then comes live load. Live load we take is 3 kilonewton. Then comes total load on going. So adding all these things, we get the 10.56. So that is on the loads on going. That means on the waste slab. Then comes load on landing. Landing is the 1 meter that I've told you, know. For that, the self weight of the landing. So 150 divided by 1000 into 25, the same method. Then floor finish, the same thing. Live load, then total load, adding all three of them. Now, you guys have understood how this works. Now, I'll be explaining you guys in the STAAD Pro. Like I'll be modeling that out, and you guys will understand how it works. See, right now I opened the STAAD model. I've already designed this. Normally, people what they do is they'll give this all this inclination, all those things. I've just taken it as a normal rectangular section, like rectangular shaped. So this is 1 meter landing that I've provided. Then is this thing 2.480, the waist slab. Then comes again the landing. So I've provided four supports. That is, these are what you call the pin supports. So this is the thing that I've provided. Then what happens is I've given a property there. So then materials are okay. Supports I've explained you now. Then comes loading. Loading, what happens is I have assigned self weight, but only to these two areas wherever the, because load will be distributed in one way slab. Normally what happens is in this case the load will be distributed to this beam and this beam, not to the side beam, because in slab, I mean staircase, so we don't provide any side beams or something like that. Only when it comes to a larger building or something like that, we provide side beams, or else usually it is like we provide beams to the these ends. So I provided that. So self weight is added there. Then comes the load that we have calculated. So as we have calculated here, whatever we see, no, base slab, sorry, to the landing, as I've told you, I've given 8.25. The same way that this side, it has given again 8.25, the one we have calculated from Excel. The same way we have calculated 10.56 on the base. So this is how it works. Now, as you guys can see now, I've added all the loads. Let me analyze this once so I can explain you guys how it works. Okay. So you guys can see the value right now. I've run the model. So here, usually what happens is whatever the value we get here, no, whatever at this side, the reactions, y and y, here also y and y. What we do is we calculate this out. So 17.599. So what we do is we add two of them. So 17.5 into 2, that means it is equal, right? So 35.18. Then we take this distance, so this is 1.5 divided by 1.5. When we do it, we get it around 23.45. So this has turned into a UDL. Then what we do, we normally, whenever we model any model or something like that, RCC building, we just add this load to the staircase area wherever the beam is provided, right? there we add this load. So this is how we do it. This is the easy way out. You guys can see a lot of difficult ways possibly. I've seen a lot of videos like that, but this is a easy way out. You guys can try this out. If you guys like the video, please do like, share, and subscribe. Thank you. Please be updated for, please do subscribe for the new videos. Thank you.